Okay, so we're going to be embarking on angles that are greater than acute angles and work with trig functions of any angle. And so there's some vocabulary that we need to get familiar with. All right, so we're going to talk about some angles, how they relate to rotations or revolutions, and degree measures. And today we are working in degree measures, not radians. So just while you're writing down your essential questions, etc., remember that an angle is a familiar figure in the world around us. Everywhere you look, you're seeing angles. Okay, and an angle is the union of two rays with a common endpoint called the vertex. And in trig, we often think of an angle as a rotation. Okay, so we start with a ray along the positive x-axis with its vertex or endpoint. Let's go back, endpoint at the origin. The other ray completes that angle after a rotation. That rotation is measured in positive or negative degrees or radians. And today we are working in degrees. Okay, and where does that come from? The measure of an angle or a rotation given in degrees was discovered or developed by the Babylonians. And the idea is they're dividing up the circumference of a circle into 360 equal parts or degrees. So if we let the measure of one of these parts be 1 degree, then one complete positive revolution or rotation has a measure of 360 degrees. Half a revolution is 180 degrees, a fourth is 90 degrees, and so on. Okay, so we are going to be working in degrees. Now let's just remind you of the standard position of an angle. We've talked about this before. Okay, so an angle in standard position has three parts. It has the initial side, the vertex, and the terminal side, okay, or the terminating side. So the initial side is on the positive x-axis with the vertex at the origin. So this is the initial side of the standard position of the angle, and it is situated at 0 degrees. And then you have this other side. Let me see if I can get a line that'll let me move it around. Okay, we have this other side. Just want to get it kind of sitting on the origin there. And this other side rotates. It rotates until it comes to rest somewhere. And then you measure how many degrees that rotation has made. And so I'm just going to go ahead and put the terminal side, terminal, part of a term we're using today. This is the terminal side, and it's the rotating side. And so depending on how many rotations you do, that's going to be the measure of your angle theta. So angles can be acute, angles can be right, angles can be obtuse, angles can be straight, and angles can be reflexive, meaning greater than 180 degrees. Okay, so we are going to be studying all the different types of angles that we could be looking at here. So let's talk about what is a positive rotation, or AKA a positive angle. So a positive angle does this. I'm going to do positive angle in green today. So here we have our angle at 0 degrees, and up here is 90 degrees. And as I rotate counterclockwise from 0 degrees, I'm finding all of the quarters of 360 degrees here, all the way back around to 360 degrees. So if my angle is going to rotate in a positive way, it's going to rotate in a counterclockwise motion. So it is counterclockwise, and it will have a positive measure. So for example, this could be possibly 210 degrees. That could be the measure of that angle. But what makes it a positive rotation or a positive angle is that I went from 0 degrees and I rotated up. Okay? A negative rotation or a negative angle in standard position would look like this. So this is 0 degrees. This would be negative 90 degrees, negative 180 degrees, negative 270 degrees, negative 360 degrees. So you can see what's happening here is you're just rotating down. So if I take my terminal side here and I rotate it to a certain position and I stop, okay, you might think that you're talking about this angle here, but we're not, because that's not a negative rotation or a negative angle. We are talking about this measure pos here, right? So that could be a measure of, say, maybe negative 315 degrees. Okay, so when we're talking about positive angles and negative angles, those angles are in standard position on the coordinate plane. Okay, and if you rotate up from the positive x-axis, that's a positive angle. If you rotate down, that's a negative. Excuse me. All right, so example 1. So the first thing that would be really useful for you to practice and learn is how to figure out, if I give you, say, a 2500 degree angle, where does the terminal side of that angle actually lie on the coordinate plane, right? And so we're going to be looking at, where does my terminal side reside, and I'm going to give you some different strategies for finding the answer to this. Okay, so for angles of the following measures, state in which quadrant the terminal side resides. It helps to sketch the angle in standard position. All right, so first of all, remember that quadrants, that's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And those are the quadrants. Those also counterclockwise, as you can see, and that's in a positive rotation. You can see you go 1, 2, 3, 4, like that, right? And this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, all the way around to 360 degrees, and then beyond. Well, this is 375 degrees, so if I'm starting at 0 degrees, I'm going to make one full revolution, and then that's 360 degrees. And then 375 degrees is just another 15 degrees, right? And so that would probably end about right there. And that would be, so this little, let me draw that again. So if I start at 0 and I rotate all the way around 360 degrees and then stop at 15 degrees above 360 degrees, I have found 375 degrees. So I could say that 375 degrees, its terminal side lies in quadrant 1. Another way you could go about this is you could pull up your calculator and just do, okay, so 375 divided by 360, and that would give you this value. So let me just plug in my calculator really quick. It gives you 1.04 approximately, right? So this represents, the 1 represents one full rotation of 360 degrees, and then 4%, that 0.04 is 4% of another rotation, right? So you could consider, I'm going to do this in a different color here, that this would be 0% of a rotation if I land on the positive x-axis. This could be 25% of a rotation. 180 degrees would be 0.5%, or sorry, 50%. 270 would be 3/4 of the way, or 75%. And so this is 0.4%, which falls between 0 and 25%. So it's 4%, falls between 0 and 25%. So it's a one full revolution, and then 4% of a revolution. That means it ends in quadrant 1. Okay, so let's do 1075. Okay, why don't you press pause and give it a go and see how you do. Okay, so hopefully you gave it a go and you came up with the answer, quadrant 4. Because as you rotate around You could do a 1075, do one full revolution, and you're down to 715 degrees. So that takes care of this first revolution here. And then if you were to subtract another 360 degrees with your calculator, that would be 355 degrees, right? And so that would take you around one full, it takes you around one more time. And then you're just going to go 355 degrees, which is pretty much almost another full revolution there. And that would give you quadrant 4. So that's another way to go about that. I also talked about down here that if you divide 1075 by 360, that's 2.99. So that's 2 full revolutions plus 99% of a revolution. So you can see that in an alternate way. Now let's do the 913 degrees, negative 913 degrees. So this time we're going to be rotating backwards, right? So negative 90, negative 180, negative 270, negative 360. All right, so if we're going backwards, how would we do this? We could take negative 913 and divide it by 360. Excuse me. And we get approximately negative 2.54 revolutions. So you would go back one time, negative rotation, two times negative rotation, and then 54 degrees of a negative rotation, or 54% of a negative rotation. So we'd have to come back 50% and then stop in quadrant 2. And so that one would look something like that. Let's move on to coterminal angles. So angles in standard position that have the same terminal side, but different measures. This is the definition of coterminal angles, right? Co meaning the same, together, terminal meaning terminating the finishing side. Okay, so angles in standard position that have the same terminal side but different measures. To find coterminal angles, start with the given angle and add or subtract multiples of 360 degrees. It's actually not that big of a deal. So here in example 2, it says find 2 positive and 2 negative angles that are coterminal to 51 degrees. Okay, so this just means that they are going to rotate around and end on the same position as a 51 degree angle. So I'm going to just zoom in here and I'm going to just take and rotate up about 51, that's 45, so 51 degrees possibly. So we're just going to call that positive 51 degrees. Now, if I want to find an angle that is coterminal to that, I'm going to grab my green pen to represent positive rotations. Then I would just rotate 360 degrees, right? And I would end up back on that ray. And so those would be coterminal. So you're just doing 51 plus 360. So if you add those together, you get 411 degrees. So an angle that is 411 degrees is coterminal to 51 degrees because they have the same terminating position on the coordinate plane as you rotate the angles around. Okay, so there's one. Now another one we could do. So we'll take our 51 degree angle here. So there it is, 51 degrees in green. And this time I want to go find another measure that will end as I rotate around. It will end up in the same place, right? So I'm going to take this line and I'm just going to rotate it around one time, rotate it around 2 times. So what I just did was I added 360 to that 2 times, right? So I went around once, around once and around twice, right? So I did 51 plus 2 revolutions of 360 degrees. And so 51 plus, that's 720. That's 771 degrees. So that is what that angle would look like. So these two are positive coterminal angles. Now we have to find two negatives. So I'm going to do one and then you do one. Right? So we're going to start with our 51-degree angle. And we'll see if we can't get it right here. About right there. Okay, so there's 51 degrees. And then I'm going to rotate in a negative 360 degrees. So starting here, I'm going to rotate it back 360 degrees and I'm going to end up there. And actually, I didn't want to do it like that. I wanted to do it like this. So back 360 degrees, right? So if I do 51 degrees minus a full revolution of 360 degrees, plug that into my calculator, I get negative 309 degrees, right? I start at net 0, go down 90, negative 180, negative 270, and then negative 309. So that is a negative coterminal angle. Now you do the last one. Press pause, and let's do 2 negative revolutions. Okay, so hopefully you were able to come up with negative 669. And so I think let's just think about how you would go about finding these very quickly with your calculator. All right, so come up with a plan for that. Now let's do the same thing with 2 positive and 2 negative angles that are coterminal to negative 7. So again, press pause. Well, I'll do the first one with you, and then you do the other 3, and then, yeah, that's what we'll do. Okay, so I'm going to zoom in here, and we're doing 2 positive coterminals to negative 7. So negative 7 would just be just slightly down, right? There's 0 degrees, negative 90. So this would be negative 7 degrees. And what we're going to do is we're going to find an angle that's coterminal to this little tiny angle right here, coterminal. So we're going to add 360 degrees, and we're going to end up in that same spot. So we're doing negative 7 plus 360 degrees, and that's going to give us a coterminal angle. Negative 7 plus 360 is 353 degrees. So I want you to think about that, right? If I take my angle at 0 degrees and I rotate it around 653 degrees, am I not 7 degrees away from 360 degrees? I mean, it makes total sense. Okay, so why don't you press pause and you find the other 3 and then come back and see how you did. Okay, so hopefully you gave that a go and you found the measures, the other 3 coterminal angles that were closest to negative 7. So another positive coterminal angle would be 713 degrees. 2 negatives that are very close to negative 7. Negative coterminal angles would be negative 637 degrees and negative 727 degrees. All right, so that's how you find positive and negative coterminal angles. All right, the last types of angles we're going to look at are complementary angles and supplementary angles. So remember that your complementary angles have a sum of 90 degrees. Okay, so you have angle theta. Let's look at this. And then up here would be angle 90 minus theta. Okay, that's how you find complementary angles. Supplementary angles here add up to 180 degrees or make a straight line. So if this is angle theta, then this is 180 degrees minus theta. That's the measure of that second angle. Okay, so to find the complement and supplement of these angles, let's look at the first one. The first angle is written in DMS, degrees, minutes, seconds. So a couple things we might want to remember. There are 60 minutes in 1 degree, and there are 60 seconds in 1 minute. So when we're doing complements and supplements and we go to subtract 32 degrees, 25 minutes, and 5 seconds from 90 degrees, we're going to have to do 90 degrees, 0 minutes, and 0 seconds in order to do subtraction. But let's see, 0, 5. All right, so how do I go about solving this? I have to borrow because I have to take 5 seconds away from 0 seconds. So I have to go all the way to here and borrow 1 degree. So that's now 89 degrees, which gives me 60 minutes. And now I can borrow 1 minute in the form of 60 seconds by going, okay, from 60 minutes, I'm going to go down to 59 minutes. And that allows me to use 60 seconds. So over here, you could write that 90 degrees, 0 minutes, and 0 seconds is equivalent to 89 degrees, 59 minutes, and 60 seconds. That way, when you go to do this math, you can use this form. So when you're doing your subtraction, it'll go a bit faster. Okay, so 60 minus 5 is 55 seconds. All right, 59, so we'll do 5. 9 minus 5 is 4. 5 minus 2 is 3. 9 minus 2 is 7. And 8 minus 3 is 5. And so the complement of 32 degrees is 57 degrees, 34 minutes, and 55 seconds. Okay, and then you're also asked to find the supplement. All right, so the supplement we start with, okay, supplement means they add up to 180. So to find the supplement, we'd have to subtract the angle from 180. So 180 degrees, 0 minutes, 0 seconds, minus 32 degrees, 25 minutes, 5 seconds. Okay, we have to borrow again. So we're going to have to borrow 1 degree. So that's 179. That gives us 60 minutes, right? And then we can borrow 1 minute. So 59 minutes allows us to change that to 60 seconds. All right, so subtract. So that's 55 seconds. And that's 34 minutes. And that's, let's see, 7, 4, 1. 147 minutes. So the supplement is 147 degrees, 34 minutes, and 55 seconds. All right, and then of course, here we have degree decimal form. And so if we wanted to find the complement, we just do 90.00 minus 71.46, and we would just do this subtraction like we would normally do it. We're going to borrow from the 9 to make the 10, borrow from the 10 to make a 9, borrow from the 10, and just borrowing all the way down. So that's 4, 5, 8, 1. So that's 18 degrees, 18.54 degrees. So the complement is 18.54 degrees. Now, when you go to do your supplement, you're doing 180 minus 71.46 degrees. And honestly, I would do this with a calculator, but, you know, just for fun. So 17, here we go, 4, 5, 8, 0, 1. So the supplement is 108.54. Now, another thing you could do, just different, is after you find the complement, you could just add 90 to it, and it would take you to the supplement. So with your calculator, you could just go 90 minus 71.46, get 18.54. There's your complement. Write it down. Then just add 90 to that, and that'll take you to your supplement shortcut. Anyway, so that's what your homework's like. And so give that a go and have a great day.